Why are humans exploring the universe more and more, the more powerless we may feel? If you stay still now, take a moment, feel it. Do you feel like you're standing still? Not at this moment. You're in constant motion, even if you don't feel it. 465 meters as the Earth rotates, at another speed of 30 kilometers per second, hurtling around the sun with Earth at breakneck speed. And the sun, we're caught in a cosmic dance spanning hundreds of millions of drifting through space. But where will we go in the end? The next 40 minutes, it will be a zero to hero version of epic space exploration. This video will show you everything we know about the universe today. But where did it all begin? For centuries, we used to think that the Earth was the center of the universe. All the other stars revolve around us. However, this illusion, proposed in Copernicus, the Earth may not be the center of the universe at all. It breaks down, and Galileo pointed his telescope up to the sky, saw the moons orbiting Jupiter, proving that not everything revolves around us. And then Kepler, by studying the orbits of planets, turns out they don't move in perfect circles. It's following precision, mathematical laws on elliptical orbits, guided by invisible forces. Now, the ancient way of bending the universe has disappeared, and we're finally beginning to understand the true meaning of these hidden movements. For thousands of years, the view of the center of the universe, of the Earth city, dominance. This view was all over the ancient world, from Chinese Tiando to Mayan cosmology. But it was in the ancient Greek cultural circle, and this idea has not only become a myth, it's a sophisticated cosmological model. 2nd century Egypt under Roman rule. Ptolemy combined all the astronomical knowledge of the time, compiled volume, published the Encyclopedia of Astronomy. In this book, he depicted a perfect and orderly universe. The Earth is the absolute center. Stay still. Moon, sun, planets, and even the entire starry sky are inlaid in a huge transparent. The sphere is like a set of delicate gears, perfectly revolving around us. But this model has a fatal flaw. It doesn't explain the retrograde. Why do some planets walk in the sky, will suddenly turn around and walk back? To fix this bug, decrypted designs become more and more complex. He added this round. You make the planet go around in a little circle, and that little circle goes around the Earth. Spin in a big circle to match the data. He invented it again. Eccentric equinox, this dressing tool. That's all. A geocentric model full of patches. Dominated the human mind for 1,400 years. He is so successful, so much so that it became legislation, the cornerstones of religion and empire. But the perfect lie, one day it will be exposed. In 1543, Europe, a book called The Motion of Celestial Bodies, quietly published. His author is a priest from Poland, Nicholas Skoberg. He spent his whole life looking up at the stars, and over the course of decades, silently calculating an idea that could turn the world upside down. He is well aware of the risks involved. I didn't dare to make him public until the end of my life. And the idea is very simple, but it was amazing. The center of the universe is not the Earth. It was the sun. And Copernicus wrote that the Earth and Mars beneath our feet, like Jupiter, just an ordinary planet. It orbits the sun every year. But he didn't stop there. Based on his observations, Copernicus proposed 3 different movements of the Earth. First, the Earth rotates on its axis once every 24 hours. This everyday rotating star, it seems to rise and fall in the sky. Second, the Earth orbits the Sun once a year. This revolution explains the change in the position of the planets and the change of seasons. Third, the Earth wobbles slightly as it orbits. Draw a small circle. We can now compare this motion to the tilt of the Earth's axis and the phenomenon of broken forks. These are not guesses. It took Copernicus decades to develop complex geometry, models, and astronomical tables. He used the triangle point to calculate the relative distance between a planet and the Sun. He's based on how fast the planets are moving across the sky to put them in order. The closer a planet is to the Sun, the faster it rotates. This fits perfectly with his observations. But despite the Copernican model, it makes sense conceptually. He didn't improve the accuracy of his predictions. This is because he still looks like he has lost his honey. Suppose the planets move in perfect circular orbits. This makes his predictions only as accurate as the old system is rather, and in some cases, even worse. And then came the telescope. It wasn't invented by scientists. Actually, he started out as a novelty in the Netherlands. A few lenses are pieced together by an eyewear manufacturer, but this strange device, let one see more than just novelty. This is Galileo Galilei. He didn't invent the telescope, but he turned it into a scientific instrument. In 1609, Galileo pointed him to the sky, and what he sees will shake the order of old friends. First, he looked at the moon through a wooden mirror. He was not perfect, as the ancients believed. Smooth, sacred sphere. It has craters, mountains, and shadows. It looks rather similar to Earth. And he looked at Jupiter, found around this planet. There are 4 little dots of light dancing. He followed them night after night, and I noticed that they were changing positions, but always close to Jupiter. These are satellites that orbit beyond the Earth. The celestial bodies are orbiting satellites. This is a huge discovery, because geocentric theory claims that everything must orbit the Earth. But here it is. Jupiter uses its own satellite system, steals the show, and he turns to Venus. And then the dust settles. Venus, like the moon, has its ups and downs. Sometimes he looks like a full moon. Sometimes it's just a new moon. This is only if Venus orbits the Sun, rather than the pain when the Earth is running. If he orbits the Earth, you will always only see one aspect of him. But if he orbits the Sun, and we're on the move, then the geometric relationship is established. That little glowing dot, it proved that Copernicus was right. But it wasn't Galileo who finally solved the math problem. It was somebody else, who didn't even believe in Copernicus at first. Copernicus and Galileo overthrew the old world, but they all left an unsolved mystery. What is the shape of a planet's orbit? The answer is hidden in a piece of data. This data comes from a man named Empire. Astronomers, he spent his life without a telescope, the most accurate star map ever made. The Empire died in 1601. This valuable data legacy handed over to his assistant, Johannes Kepler's hands. It took Kepler 8 years. Die hard for this pair of data, especially the most Disobedient Mars. He tried everything, trying to fit the orbit of Mars into a perfect circle. Shape but fail. Finally, he gave up his obsession with the perfect prototype. Let the data speak for itself. At that moment, the true laws of the universe were revealed. The orbit of the first planet is not round at all. It's an ellipse. The speed of the second planet is not constant. The closer they get to the sun, the faster they run. The orbital period and orbit of the third planet are large. There is an exact mathematical relationship between it's called Kepler's 3 laws. Copernicus lit the fire. Galileo provided the evidence. And Kepler. Mathematics was used to compose the movement of the new universe. But a new problem arose. What invisible force is conducting this grand cosmic dance? Why don't planets leave their orbits? Won't fall into the sun? The answer came from a falling apple and a giant named Isaac Newton. Newton realized that the power to bring apples to the ground, it's the same force. He gave it a name, attractive force. He used a simple law, the law of gravity, unified heaven and earth, from the apple to the planet. The motion of the entire universe has a single explanation. Using Newton's mathematics, we can finally calculate with precision the speed of the Earth's revolution, 107,000 kilometers per hour. Mercury is faster. Mars is slower. Everything fits together. So far, the millennial mystery of planetary motion has finally been solved. The answer is attractive force. But there's something else, something no one expected. Because when scientists use better tools and more accurate mathematics to map the sky division, they noticed another movement, a bigger, deeper movement. We used to think of the sun as the resting center. It's not static. He is also moving. But where is he going? After the Copernican revolution, the sun replaced the Earth as the center of everything. The universe no longer revolves around us. It's the Earth in motion, rotation around an axis, and orbits the sun. The idea feels revolutionary, but once the paradigm shifts, the new Rickson model begins to take root in people's hearts. The sun becomes the still point of our universe over the course of hundreds of years, and that idea stuck. But that's about to change. It's not physicists who bring change. I'm not a philosopher. It was a musician named William Herschel. Herschel had an obsessive hobby building telescopes. The lenses he polished by hand. The performance far exceeded all products at that time. When he pointed the telescope at the sky, what he did was not observe. It's about counting the stars. He wanted to know if the distribution of stars was random, or is there a pattern behind it. Therefore, he started the investigation in the dumbest way. He and his sister cut the sky into small pieces. Count piece by piece in which direction there are more stars, and as a result, a startling picture emerged. The distribution of stars is not uniform. In a certain direction, they are dense, like a band of light. That's what we call the Milky Way today. Herschel drew the first pair accordingly. Cosmic structure diagram. In his opinion, the universe is like a giant flat disk, and the sun is located near the center of this disk. We know today that his map was wrong. He didn't know there was interstellar dust, and the force that keeps the moon in orbit, blocking the farther stars. He doesn't know those blurry nebulae. It's actually a more distant galaxy, and he thought the disk was the universe. But at the end of the 18th century, this is already a revolutionary discovery. He proved it for the first time. Stars don't walk indefinitely. They form a structure-shaped system, and we are in it. And that discovery raised a whole new question. If galaxies had shapes, then we have a place. If we have a location, are we also exercising? At this time, people started asking the deeper question, where the hell are we, and how to determine what is athletic? What doesn't move? Because if everything is in motion, how do you know what is static at this moment? We hit a wall. It's not a wall of data. It's a wall of perspective. Because everything we see comes from here. Seen from the Earth, our eyes, telescope, the instruments all sit on this spinning rock. And the rock itself is orbiting the sun. And the sun, as Herschel suspected, may also be moving. So how can you tell what's really moving? What? Nothing. This involves a frame of reference. Let's do a simple thought experiment. Imagine you are sitting on a train, drinking coffee, reading a book. Out the window, you see another train next to you. For a moment, you think that train is sliding backwards, but that's you moving. Or is he moving? Or are you both moving? Here's the thing. If you don't look at the ground, you can't be sure. This is the trap of your frame of reference. Inside the train, everything feels static. The coffee stays well in the cup. The book rests quietly on your lap. But for those who stand on the platform, you are spending every hour at a speed of 80 kilometers. So who is right? Actually, both are true. Because motion is not absolute, it's relative. And when your only window to the universe is from this moving train on a rotating Earth, orbiting a star that is also moving. So figure out what's really moving. It's a puzzle. The question posed by Herschel in the mid-19th century by a Dutch astronomer, Jacobs. Captain sets out to solve. He is quiet and cautious. A person who speaks with numbers. Astronomers at that time. What is no longer needed is a better telescope. It's a new approach. What Captain brings is this new approach. He no longer just looked at the position of the stars. They started measuring them, LIF. That is, the tiny annual displacement of a star across the sky. He has collected a huge amount of data from all over the world, tracking bit by bit the drift of thousands of stars. Then a strange pattern emerged. Stars in the sky. It seems to have split into two huge star streams, like rivers in two universes, flow in the opposite direction. At first, everybody thought it was the stars, but Captain offers a subversive perspective. If it's not the stars that are moving, it's about us. It's like you're walking through a crowd. It feels like people on both sides are backing up. But it's really just because you're moving forward. Captain recalculated using this idea. It all makes sense. Those two so-called star streams. Just our sun, with the entire solar system. The vision produced by traveling between stars. Illusion, according to his calculations. The sun is traveling at 20 kilometers per second. Drifting steadily towards 5,000 seats. This direction came to be known as the solar point. After the Earth, the sun has also lost his privilege of standing still. The spear point of our universe has changed again, subsequently, but Kabutin poses an even bigger question. We're in the star system. What does he look like? He uses the brightness and motion of stars, constructed his model of the galaxy. This is our first time to really try to map the entire galaxy. A flat disk, about 40,000 light-years in diameter. The sun is located near the center of this disk. Certainly, we now know that Capitan's universe is too small, because he didn't know that between the stars, floating vast amounts of light-absorbing interstellar dust. This dust is like a dense fog in the universe, made him seriously underestimate the true size of the Milky Way, but it was groundbreaking at the time. Where did he take astronomy from us? Brought what new heights are we in the system? It is also, at this time, a new mystery that has puzzled all astronomers. The blurry ones in the sky emerged, a light spot like a vortex. The so-called whirlpool nebula. What are they? Small gas clouds in the Milky Way galaxy. It's as far away as the Milky Way. Independent cosmic island. The whole astronomical community has been arguing about this until a person appears, ended the debate once and for all. And here comes Edwin Hubble. In 1923, Edwin Hubble used the world's most powerful telescope at the time, aimed at the most famous whirlpool nebula, Andromeda. He found one called special stars with belly variable stars. This kind of star is like the standard candle in the universe. His flashing frequency can be used directly to calculate his true distance. When Hubble calculates the result, he was shocked. Andromeda is beyond imagination. He's not in the galaxy at all, but beyond the Milky Way. This discovery completely shredded the human view of the universe. The entire universe we think of. The Milky Way is just a vast expanse of space, one of the billions of cosmic islands, the scale of the universe under Hubble's telescope. It was stretched countless times in an instant. This finding has a larger significance as well. We finally have a mirror. We can't see ourselves outside the galaxy, but it can be passed. Observe outer galaxies like Andromeda to reverse the appearance of our own home. And a man named Dutch astronomer Jan Olt make formal use of this idea. Solved the next puzzle. He discovered that stars near the sun move very strangely. They don't look like it's synchronized, like a float on the wheel. Spin some fast and some slow. The entire galaxy is more like a giant vortex. Oort calculated the truth. The Milky Way is undergoing a poor rotation. He spins fast around the center, slow on the edge. And he came up with some startling statistics. Our sun is far from the center of the galaxy, about 30,000 light-years. It's going at a terrifying speed of over 200 kilometers per second. Take us around the silver core. It takes 225 million years to go around. This is a galactic here. Every star you see in the night sky, they're all doing the same dance. We are all in this huge spin, just because of exercising together. So unconscious, but new problems ensued, since the entire galaxy is rotating. So what are we rotating around? To answer this question, we need a new pair of eyes that can penetrate cosmic dust. So astronomers turned to radio waves, with 21 centimeters that can penetrate dust. atom clearing signal, for the first time we came from within, depicts the suspended structure of the Milky Way. But that's not enough. We need to see better, see more accurately. This is the most powerful tool in the history of astronomy. Here comes one of them. Good at Mechanical Array, VLBA. It's not a telescope. It was found all over North America. Array of radio antennas. They work in sync. It's a virtual continent-spanning thing. Super telescope. Its precision, high enough to rise from the Earth. See a coin on the surface of the moon. Utilize VLBA. Astronomers began to track. Some of the galaxies are called wheat. Z's natural radio beacon. These beacons are like beacons in the universe. By precisely measuring their three-dimensional motion, we can finally map the complete picture of stars dancing in the Milky Way galaxy. The result shows all the stars are orbiting the center of the galaxy, but there is one phenomenon that puzzles everyone. Closer to the center of the galaxy, the faster the star goes. Incredibly fast. But the visible matter there, stellar gas, dust, its attractive force. There's simply not enough to bind these hurtling stars. This means that there is a huge, deadly but invisible, right there, acts as an attractive force anchor for the entire galaxy. All the observational data, they all end up at the same coordinates, one in the direction of Sagittarius. Mysterious radio spot called Sagittarius A. Under visible light, it was unremarkable, but in the radio band, and he's incredibly bright. VRBA observations confirm he was almost motionless, and everything around, they're all revolving around him like crazy. His mass is more than 4 million times that of the Sun. It's smaller than the orbit of Mercury. In physics, only one thing can satisfy so much at the same time, and so tiny these two conditions. A supermassive black hole. This is the center of our galaxy. Its sustaining numbers, ultimate source of attractive force for hundreds of billions of stars. He sat there quietly, dominate everything. But the story is far from over, because even our entire galaxy, this massive vortex dominated by a black hole, he's not standing still. He, along with hundreds of galaxies around him, it is being overwhelmed by a broader trend. A more mysterious force pulls a cosmic drift on a larger scale. Imagine a car speeding towards you, engine roar. Just as he passed by, the sound has changed. Higher pitch as you approach. Far from reality is lower. This is the Doppler effect. Sound waves like this. The same is true of light waves. If a galaxy is moving towards us, his light waves will be compressed. Move towards the blue end of the spectrum. We call it the blue meter. If he is away, the light waves get stretched. Move towards the red segment. It's called a red instrument. In the early 20th century, scientists are starting to take advantage of this technique to measure the motion of galaxies. One of them was Edwin Hubble, and what he found shocked the world. He observed, most galaxies are moving away from us, and the farther away you are, the faster you run. Some fly away at hundreds of kilometers per second. Some are thousands of kilometers high. What Hubble discovered was that distance increases the faster it goes. That means that space itself is expanding, and all galaxies, it's all just following this trend. This finding is significant. Not only did he contribute to the later Big Bang theory, laid the foundation, it also revealed that the universe had a common beginning. But not every galaxy is moving away. Our most familiar neighbor, the huge Andromeda Galaxy, is an exception. As early as 1912, astronomer Silver discovered Andromeda's spectrum is blue. That means he's coming our way. But that was all they knew. Just one direction. Fast forward 100 years. Technology has been turned upside down. Astronomers combine the Hubble telescope, Gaia satellite, and VLBA data. Not only did I see the light of Andromeda, and tracked his lateral movements precisely for years. And you get a complete three-dimensional trajectory. The results confirmed Andromeda is not simply passing by. He has been locked by attractive forces. He is working with the galaxy on a direct collision trajectory, and we're getting closer. We're both traveling through galactic space. Run towards each other. Current Andromeda, heading towards us at 110 kilometers per second, and our galaxy, they go up at nearly 300 kilometers per second. Add up, the distance between us is approaching 500 kilometers per second. The speed in the... Of course, space is huge. Andromeda is 2.50 million light-years away, even at such an alarming rate. This encounter also takes a long time. Not tomorrow, not next year, but after about 40 to 5 billion years, the two galaxies will finally meet. You may think this is a constant, the disaster of star collisions, but that's not the case. The interiors of galaxies are extremely empty. If a star is a ping-pong ball, the star closest to him, also hundreds of kilometers away. So the vast majority of stars will be in collision, passing by unscathed. Real drama stars come from attractive forces. This invisible force will pull, distort to galaxies. He'll throw out a long stream of stars. We call it Chow Shui. He will tear the cantilever, ultimately pulling the cores of the two galaxies together, merged into a larger and more chaotic elliptical galaxy. Astronomers have given this future home name: Milky Way Andromeda Galaxy, our sun. Then you may be dumped into a brand new one, on a more irregular track. But the collision with Andromeda, it's not the whole of our journey, because the Milky Way, Andromeda, and hundreds of nearby galaxies are being pulled by a greater force, moving in the same direction. To understand this, we have to look beyond that. Galaxies don't exist in isolation. They run down like water, following attractive forces to form a group. Our Milky Way galaxy, it belongs to a local group of about 80 galaxies. And the local group, it's just another inclusion. The Virgo cluster of thousands of galaxies, a small member of our entire local group of galaxies, is traveling at 600 kilometers per second, pulled towards the center of the Virgo cluster. But that's not the end. Above the cluster of galaxies is a supercluster of galaxies. We are in the Laniakea supercluster, a light-year across 500 million, with 100,000 galaxies. It contains the Virgo cluster and several other massive superclusters around it. All of this are all connected by the flow of the cosmic web. So how do scientists know all this? They need more than just red and blue meters. We also need to calculate the intrinsic velocity of the galaxy. That is, after stripping away the effects of cosmic expansion, real motion caused by local attractive forces. Through large sky surveys like Cosmic Stream, scientists have mapped our cosmic shower. 3D velocity map. The results were shocking. Galaxies are not just expanding uniformly outward. They're still headed in a certain direction, going on a grand. It's a coherent flow. This flowing destination, located in a galaxy surrounded by dust, blocked area. We call this the occult zone. Back in the 1970s, astronomers noticed this mysterious pull. They named the source of this attractive force. We can't see him, but I can feel his attractive force. Our entire galaxy cluster is attracted to him. By X-ray and infrared surveys, we gradually lifted the veil. It's not a single object. It's a region teeming with galaxy clusters. The most central structure. It's a much larger, sharply supercluster. This is what's pulling us. The attractive force of the sharply supercluster is so strong, so that our entire Laniaceus are traveling at 600 kilometers per second, being dragged towards him. But it's more like a cosmic tug-of-war. Except for the pull of the actors, there is also a strange character at play. Our path, Ogezi Chuan. It's not an object. It's an incredibly empty cosmic void. There's almost no substance there. No attractive force. But it's this emptiness that acts as a repulsion. Imagine you are in a river. On one side is the giant Yinyuan waterfall that pulls you past. On the other side is the calm water of Ogeko. You were not pushed, just didn't get pulled. So you naturally flow towards the waterfall. Our galaxy, it falls into such a after the attractive force, but even so, it's still not the end of the universe. When you look as far as you can see, beyond all superclusters and voids, a new paradigm began to emerge, a deeper flow across the entire observable universe. All the threads of the cosmic web, they're not standing still. They're headed somewhere. So far, we've been following the rotation of the Earth, watching the sun drift through the galaxy. We're zooming in. See the entire galaxy itself. We are also moving towards a place where we cannot. A large source of attractive force. Just think, we are on a moving rock. And this rock, it's part of a mobile system. This system is still in a moving galaxy. Now, that's crazy enough. But now, it's time to look bigger. It's time to ask one last question. Where does everything in the universe end up? Not just the Earth. It's not just our hearts. It was everything. What is the ultimate destination of the universe? To answer this question, we have to talk about something strange. He doesn't shine. Not shining, but seems to be manipulating everything behind the scenes. He's so weird. So much so that his discovery shook the entire scientific community. Ironically, this story, it began when scientists tried to predict the end of the universe. In the 1990s, to independent scientific teams, I started working on something called Type I, supernova exploding star. This supernova is the perfect cosmic milestone because the way they explode is almost identical, constant brightness. So, by observing their light and dark, you can accurately determine their distance. Their goal is measuring the slowing rate of the expansion of the universe. You heard right. is slowing down because the prevailing assumption was that after the Big Bang, attractive force like brakes, slowly pulling on the expanding universe. But that's not what the data shows. When they measured supernova, found something that doesn't match at all. Those distant galaxies are even more distant than expected. Their light is redder than it should be. This means that instead of slowing down, the expansion of the universe is not slowing down. It's accelerating. Imagine that. You're a physicist. Suddenly found all assumptions about the future of the universe are incorrect. Here is what happened in 1998. After repeated verification, the results are consistent. Something invisible, powerful stuff, is pushing the universe apart faster and faster. They call this mysterious force dark energy. We don't know what dark energy is. We don't even know if it's an entity, but we know it's real and rule the universe. Of all the energy and matter in the universe, it's about 70% dark energy. To understand how strange that is, think of it this way. Everything you've ever seen or touched in your life, including all stars, planets, and atoms, that adds up to less than 5% of the universe. The other 25% is the dark matter that holds the galaxies together. And the rest of the universe, the largest piece, it is this force that silently pushes the universe apart. So what could he possibly be? Physicists have a few guesses. The most direct idea is dark energy is the vacuum energy of space itself. That is to say, even empty spaces, filled with tiny quantum mastery. And here's the interesting thing. Quantum theory does predict a vacuum. It should have energy. But the craziest part is, theoretically predicted energy value than we actually observe. To strengthen the 120 defenses of a full 10. This is the history of physics. The greatest discrepancy between theory and observation. It is like weighing a feather with a delicate instrument. It turns out to be heavier than the entire Earth. Here's the thing. According to Einstein's theory, energy itself affects the structure of space-time. So if space really does have energy, he will affect the expansion of the universe. The universe we observe is accelerating its expansion. This has led scientists to believe that maybe vacuum energy is dark energy, but that catastrophic numerical bias tells us either there's something wrong with our theory, or we're missing some big puzzle piece. We can think of space as a place that is drying. Roasted raisins. The bread galaxy is the raisin inside, as the bread swells away from each other. But dark energy, it's like someone turned the oven on full fire halfway through. It doesn't just swell, it's expanding faster and faster, and the bigger the bread, the faster it expands, because dark energy is space itself. More space, the more dark energy there is. It won't dilute, it won't run out. That's weird enough. But here's the really disturbing part. Where is that taking us? This leads to the study of cosmology. One of the scariest predictions, the big rip in this scenario. The acceleration of energy is relentless. It's accelerating. At first, it was just drifting between galaxy clusters. The sooner, but eventually, the force of the expansion will be so powerful that it will tear apart the galaxy itself. Then he'll tear apart star systems. The planet is thrown out of orbit, and then he'll tear the planet apart, even tear apart the atoms that make up matter. In the final moments of the Great Rip, The universe will become a storm of countless negative energies, and of course, this is just a model. Will it ever happen? It depends on what we don't know, the true nature of dark energy. Another possible behavior is the big squeeze. This theory postulates that at some point in the future, attractive forces may return, take back control, the expansion of the universe will stop, then reverse. All the galaxies will start moving closer together. The universe will contract. The temperature rises sharply. It finally collapses into a hot and dense starting point. It's like a cosmic cycle from the Big Bang to the end of the big squeeze, over and over again. But here's the thing. All of our current observational data both point to accelerated expansion rather than slowing down, so a big squeeze is unlikely. We don't fully understand what dark energy is. He's just one that we can measure. But unexplained standing suit. But based on what we currently know, there is a third. It is also the most likely outcome. He's not violent, like tearing or squeezing. He just walks to the end in silence. This is the big freeze. In this scenario, dark energy will continue to drive the expansion of the universe smoothly. The heart will get farther and farther. Never look back. The stars within them will run out of fuel one by one, then extinguish. According to the best data we have available, this could very well be the ultimate fate of our universe. Now, let's follow this future step by step. The era we are currently in. Stars are still being born. Life is still breathing. But time passes, many, many hours. 100 billion years after, as space expands faster than the speed of light, the vast majority of galaxies will disappear from our sight forever, like ships sailing through the universe. Our Milky Way galaxy, it will become a floating place in the endless. Island in the dark, about 1 trillion years later, due to fuel exhaustion. Star formation throughout the universe would come to a complete halt. The remaining stars will slowly burn themselves out, and the red dwarf is the final beacon. They can burn for trillions of years, but even they will eventually go out. After that, the stars go out. Only icy wreckage remains. White dwarf neutron star. Black holes. We enter what's called the degenerate era. There's no starlight, no new age, only endless darkness and devouring time, still on a scale we can't imagine, after hundreds of billions of years. Even the debris itself began to decay. The white dwarf cools into a black dwarf that does not emit light. And according to Hawking, black holes are not eternal. They will pass Hawking radiation extremely slowly, evaporating itself. A solar mass black hole, it takes 67 years to disappear completely. The history of the universe as we know it, a drop in the ocean at a time like this. Eventually, the last black hole also evaporates. There are no more stars in the universe. There are no planets, no light. There are only a few solitary elementary particles left. Floating in a dead silence, in the cold and infinitely expanding space. The temperature is infinitely approaching absolute zero. Even matter itself may cease to exist. If proton decay is real, then all the substances we are familiar with will completely fall apart. What will be left by then? Maybe there's nothing left. Only one from the distant past. Weak background radiation, like a faint sigh, prove that stars have burned here. Heart and life. Remember the question we asked at the beginning. Why do we explore the universe more deeply? The more desperate I feel, because we find that all our movements drift from Earth to galaxies, to the expansion of the universe. This event runs through time and space. Big and involuntary journey, its end. It could be such an eternal void, and silence, we use science. Draws a grand map from start to finish. We know where we came from, and where we might go. We understand the laws that drive everything. But these laws, finally, but it points to a place that no one can decipher anymore. Their future. We are like a group on a huge ship doomed to silence. The route was accurately calculated, and the traveler of silent time. And now you are sitting on this ship at a speed of 30 kilometers per second. Continue this endless drift. So what do you think the meaning of this journey? What exactly is it?